Okay, are you ready? Buckle up, space fans, because today we're going to launch into the world of lunar exploration, but with a twist.
Like twist.
Yeah, twist. Today we are diving deep into NASA's CADRE mission. So imagine, just picture this, not one, not two, but three. Three autonomous rovers roaming the moon. Just roaming.
Wow, that is a lot of rovers. So what are they going to be doing up there?
Well, that's the really cool part, right? What's really captivating is that they won't have a human controlling them.
What?
Yeah, no joystick, no remote control.
That's crazy.
Just robots. Suitcase-sized robots, by the way.
Wow.
Working as a team.
Like a little team.
Yeah, like a little rover gang, making decisions on their own.
How do they make decisions?
AI, artificial intelligence.
AI, okay. I mean, that sounds straight out of science fiction.
It really does.
Yeah.
But before we get lost in the what-ifs, let's bring it back down to Earth for a second and break down what these rovers will actually be doing up on the moon. You know, the nuts and bolts.
Oh, okay, yeah, I'd like to know that.
So they have an official mission, believe it or not.
Of course they do. They're NASA rovers.
And that mission is to explore the Reiner Gamma region.
Reiner Gamma region. Where's that?
A mysterious area on the moon's western near side. And they're going about this mission, these little rovers, in a pretty cool way. They're using cameras and ground-penetrating radar to create a map.
A map, okay.
Of the surface and what lies beneath. So think of them like robotic archaeologists.
Robot archaeologists on the moon. I mean, you've definitely got my attention now. But why that particular spot, though?
I know, right.
What makes Reiner Gamma so fascinating to scientists?
Well, I'm glad you asked, because it's a swirl.
A what?
A swirl, a bright swirling pattern on the lunar surface that scientists have been puzzling over for decades. We don't fully understand how these swirls form. It's a mystery. But one leading theory points to magnetism.
Magnetism.
Yeah.
I'm intrigued. How does that work?
It's pretty complex.
Okay.
But essentially, the idea is that these swirls might be areas where the moon's magnetic field is somehow protecting the surface from the solar wind.
Oh. Okay.
So this magnetic shielding, we'll call it, could explain why these areas, these Reiner Gamma swirls, appear brighter. Because the surface material hasn't been darkened by the constant, bombardment of charged particles from the sun.
Oh, so the magnetic field is like a shield.
Yeah, like a little force field protecting the surface.
Wow. Okay.
So by mapping Reiner Gamma, these rovers, right, could actually help us unlock the secrets.
The secrets.
The secrets of these strange magnetic swirls and how they interact with the solar wind. It's pretty wild.
Yeah, that's pretty wild.
But that's just one piece of the puzzle.
Just one piece.
Yeah. I mean, this mission is really, really about testing the limits of something that we call autonomous exploration. Remember,
cool.
KDR stands for?
Cooperative.
Okay. Cooperative.
Autonomous, yeah.
Distributed.
Exploration. Exploration, got it. Okay. I remember now. You said it earlier. The rovers, they're working as a team.
Exactly.
Like a little team.
Yeah, it sounds like a big technological leap.
Oh, yeah, absolutely.
Can you unpack that a bit more? What makes this mission so groundbreaking in terms of AI and robotics?
I mean, think of it this way. Until now, right, most robotic missions in space have required, constant communication with Earth.
Right.
Every command, every movement had to be planned, had to be executed by humans.
Yeah, by us.
Right. But with CADRE, these rovers will be making many of these decisions all on their own.
On their own. So we're talking about robots that can, think for themselves.
Yeah.
Adapt to their environment, and even work together to achieve a common goal.
Exactly.
That's crazy.
Yeah, they'll be using sophisticated algorithms to analyze data from their cameras, their sensors.
Okay.
Navigate challenging terrain, and even coordinate their activities as a team.
It's a huge step, isn't it?
Oh, huge step.
Towards creating robots that can explore and conduct scientific research without, needing us to babysit them constantly.
Exactly.
That is a game changer.
Yeah.
And I mean, it sounds like it could open up incredible possibilities.
Oh, yeah, absolutely.
For future missions. I mean, not just on the moon, but maybe even on Mars or beyond, right?
Oh, absolutely. If KD is successful, and I think it's going to be, it could pave the way for robots to take on, even more complex tasks in space, like building habitats, collecting resources, conducting experiments, all with minimal human intervention.
So it's like a whole lunar workforce.
Yeah.
Okay. So we've got these incredibly sophisticated robots, a mysterious lunar location, the potential to revolutionize space exploration. We've painted this really, really vivid picture.
It's exciting.
But before they can head off on their grand adventure,
yes,
they got to get there first.
That's true.
Can you walk us through the journey that these rovers have taken to get ready for their lunar debut?
So they started their lives at NASA's Jet Propulsion Laboratory, JPL.
JPL.
Yeah. And that's where they were, meticulously designed, built, and tested. But getting a robot ready for space, it's no easy feat.
I can imagine.
Oh, yeah. It's a ton of work.
What kind of preparation goes into making sure they can survive the trip to the moon?
It's an incredibly rigorous process. Just picture this.
Okay.
Each rover, to prepare for launch, each rover was flipped over, carefully attached to a plate, and then sealed inside a protective enclosure.
So it's like packing them up for a very, very important move.
Exactly. And all of this is to ensure that they can withstand the intense vibrations and forces, of launch and landing. It's intense. And then just a few weeks ago, they were shipped off.
They got shipped?
Yeah, to Intuitive Machines in Houston.
Oh, okay. Intuitive Machines.
Yeah.
In Houston. And that's where they'll be integrated with the lander that will actually take them to the moon.
Yes. It's quite the delicate dance getting all the components ready.
All the components?
Yeah. The rovers, a base station for communication, and even a special camera system to monitor the experiment.
Wow.
All ready for their lunar debut.
That's incredible.
Yeah. Yeah, it is. It's a true testament to the collaboration and engineering brilliance involved in space exploration.
Yeah, it really is. But all this talk of rovers and landers makes me wonder, how do they actually get up to the moon? Is there a special rocket just for this mission?
That's where NASA's Commercial Lunar Payload Services Initiative comes in, CLPS for short.
CLPS.
Yeah. Instead of building and launching their own rockets for every mission, NASA is partnering with private companies.
Oh.
Like Intuitive Machines to get payloads to the moon.
So it's like a lunar rideshare program.
Yeah, you could say that. It's a way for NASA to, leverage the innovation and expertise of the private sector while also kind of, fostering a more sustainable and cost-effective approach to space exploration.
That makes a lot of sense. So our rover trio is hitching a ride with Intuitive Machines on their IM-3 mission.
Right.
When can we expect to see this launch happen?
The launch window is set for early 2026. And here's another interesting tidbit. The CADRE rovers aren't the only passengers on board. No.
Yeah.
IM-3 will be carrying a variety of other scientific instruments and experiments.
So, what else is going along for the ride? Is there anything particularly exciting or unusual about these other payloads?
There are a few that stand out. One is a lunar hopper called Micronova.
Micronova.
Yeah. And it's designed to take short hops, across the lunar surface, exploring different areas and collecting data on lunar geology and resources.
Wait. A hopping robot on the moon?
Yeah.
That's pretty cool.
It is cool.
Anything else?
There's also a laser retroreflector array that will be placed on the lunar surface. This will allow scientists to measure the distance between the Earth and Moon, with incredible precision, which, helps us learn more about the Moon's orbit and its relationship to our planet.
Wow. Okay, so it sounds like IM-3 is going to be like a busy flight.
Oh, yeah.
There's a whole lunar science lab packed onto one lander.
Okay.
But let's zoom back in on our intrepid rover team. Yeah. We've talked about the what and the how of the CADRE mission, but what about the why?
The why?
What's the bigger picture here? Why is NASA investing in this kind of autonomous exploration?
It's a question of looking ahead, right?
Okay.
Right now, we're still in the early stages of lunar exploration.
Right.
But as we set our sights on, more ambitious goals like establishing a permanent human presence on the moon, building lunar infrastructure, and even using the moon as a stepping stone for missions to Mars, we're going to need help.
And that's where robots come in.
Exactly. Robots, like the CADRE rovers, could play a vital role in this, future lunar ecosystem.
Okay.
Think about it. Robots that can scout out potential landing sites, help build habitats, maintain equipment, and even extract resources, all without needing constant human supervision.
It's like a whole lunar workforce. But I do have one question.
Okay.
If these robots are so autonomous, so good at making their own decisions, does that I mean, does that mean humans are out of the picture entirely?
Not at all. It's more about shifting the dynamic.
Okay.
Instead of, micromanaging every move, humans will take on more of a supervisory role, setting goals, providing guidance, and stepping in when needed.
So collaborative partnership, humans and robots working together to explore the moon and beyond.
Precisely. It's about leveraging the strengths of both humans and machines to achieve things that neither could do alone. And that, I think, is what makes CADRE so exciting. It's not just about sending robots to the moon. It's about reimagining the future of space exploration and pushing the boundaries of what's possible.
Well said. You've definitely got me thinking about all the incredible things that we might achieve with this kind of technology. But you mentioned Mars earlier. Do you think that autonomous robots could play a role in human missions to the Red Planet?
Absolutely. In fact, I think they're essential.
Okay.
Mars is an even more challenging environment than the moon. Much farther away, more extreme temperatures, and a much, much longer communication delay.
Oh, wow. Yeah.
So having robots that can operate autonomously, make decisions on the fly, and adapt to unexpected situations will be crucial.
So we could have robots scouting out landing sites, setting up habitats, and maybe even conducting preliminary scientific research before humans even arrive.
Exactly. Imagine a team of robots that have already, set up a basic camp, deployed scientific instruments, and maybe even started growing food in a Martian greenhouse.
Yeah.
All before the first astronauts even set foot on the planet.
That would be incredible.
Yeah.
And it would certainly make things a lot easier for those first Martian explorers. But what about those unexpected situations that you mentioned?
Right.
How do we ensure that these robots are making the right decisions? Especially, when they're millions of miles away from Earth.
That's where the real magic of AI comes in, right? These robots will be equipped with sophisticated algorithms that allow them to learn from their environment, analyze data and make decisions based on their programming and the information that they gather.
So it's not just about following pre-programmed instructions. They can actually learn and adapt as they go.
Exactly. It's a constantly evolving field, and the AI that powers these robots is getting more sophisticated all the time.
Right.
They can, assess risks, identify potential hazards, and even come up with creative solutions to problems that we might not have anticipated here on Earth.
That's both impressive and a little bit mind-blowing. But it also makes me wonder, with all this autonomy, all this decision-making power, are we essentially creating robots that can think for themselves? And if so, what are the implications of that?
That's a very profound question, and one that we'll need to grapple with as this technology continues to evolve.
It certainly raises a lot of interesting questions about the future of AI and its role in space exploration. But before we get too lost in philosophical discussions, let's bring things back down to Earth. Or rather, back to the moon.
Oh, yeah.
We've talked a lot about the potential of autonomous robots, but what are some of the specific challenges that the CADRE mission will face? What are the things that could potentially go wrong?
Well, I mean, the lunar environment is unforgiving. It's a world of extreme temperatures, harsh radiation, and the constant threat of micrometeoroids. Any one of these factors could pose a challenge to the rovers.
So just surviving on the moon is a challenge in itself.
Absolutely. And then there are the challenges of navigation.
Okay.
The Reiner Gamma region with its swirling patterns and potential magnetic anomalies, could throw some unexpected curves at the rover's navigation systems.
So it's not just about driving in a straight line.
No.
They'll need to be able to adapt to unexpected terrain,
right,
and potentially even reroute themselves if they encounter obstacles.
Precisely. And remember, they'll be doing all of this while communicating with each other and coordinating their activities as a team.
Right.
It's a complex dance.
It really is.
Any number of things could go wrong.
It sounds like the team at JPL has their work cut out for them.
Yeah.
But they've certainly got a lot of experience designing and building robots for challenging environments. Do you have a sense of how confident they are in the CADRE mission success?
I think they're cautiously optimistic.
Cautiously optimistic.
They've put these rovers through rigorous testing, simulating lunar conditions as best they can here on Earth. But ultimately, the true test will come when the rovers, touch down on the lunar surface and begin their mission.
It's a reminder that space exploration is inherently risky even when we're sending robots instead of humans.
Absolutely. There are always unknowns, always factors we can't fully anticipate.
Which makes it all the more exciting, right? It's that element of the unknown, the possibility of discovery that drives us to explore.
Exactly. And with KIR, we're not just exploring a new world, we're exploring a new way of exploring.
You've definitely given us a lot to think about, from magnetic swirls to hopping robots, lunar ride shares, and the future of AI. This deep dive has been quite a journey.
It's been a pleasure sharing these insights with you.
And with our listeners. But before we wrap things up, I have one final question for you. If you could sum up the significance of the CADRE mission in just one sentence, what would it be?
CADRE, it represents a paradigm shift in space exploration, where robots and AI become our partners in discovery, paving the way for a future where humanity's reach extends far beyond our planet.
Wow, that's a great way to put it, a paradigm shift.
Yeah.
It really does feel like we're on the cusp of something truly transformative. And as you said earlier, this is just the beginning.
Exactly. CADRE is a stepping stone, a proof of concept that will open up a world of possibilities for future missions. And as the technology continues to evolve, who knows what we'll be capable of achieving.
It's exciting to think about. We could have robots building outposts on Mars, mining asteroids for resources, maybe even exploring the icy moons of Jupiter and Saturn in search of life.
The possibilities are truly endless. And as we push the boundaries of what's technologically possible, we'll also be pushing the boundaries of our own understanding of the universe.
That's what makes space exploration so captivating, isn't it? It's not just about the science and technology. It's about the wonder, the mystery, the quest to understand our place in the cosmos.
I couldn't agree more. And I think missions like Cydia, with their blend of cutting edge technology and bold ambition, will inspire a whole new generation of scientists, engineers, and dreamers to look up at the stars and ask, what's next?
What's next, indeed. And we'll be here at the Deep Dive to keep you updated on all the latest developments, from lunar rovers to Martian outposts and everything in between. Thanks for joining us on this incredible journey.
It's been my pleasure. Always a thrill to dive into the future of space exploration.
And for our listeners, until next time, keep looking up and never stop exploring.